This video is the first set of notes on ellipses. So similar to the way we did parabolas, we're going to divide our paper vertically in half. But before we do that, let's first talk about the definition of an ellipse. It is a set of all points in a plane whose sum of distances from two fixed points, which we call foci, is constant. Let me show you a quick video on how this principle works in terms of getting two fixed points. We're going to get one here and here. We know that is set, so we know that distance is the same no matter what. And then we're going to get some string and be able to see that the sum of these three sides is always a constant. We know this one, that's the distance between the two foci, but these two guys over here actually change. So watch the video. So here are the two fixed points. We're going to put a string around them. That's a fixed string. We're going to make sure it's taut, so that way, tight, is that what that means? We're going to get a marker, and then we're going to make it go all the way around, keeping the string kind of tight, and we can see that the sum of the string, the distance of that string, is still a constant no matter where we put our marker. It's going to go all the way around the two foci, those two fixed toothpicks, until we complete our ellipse. First, let's dissect the ellipse. So one of the most critical points that we're going to find is going to be the center. We'll label that one C. And we already talked about two fixed points, which we called the foci. We're going to think of this as F, and we're going to call it sub 1, and we'll call this one F sub 2, since we have two foci. Big things to remember is that we also have vertices, a vertex over here and another vertex over here. You'll probably hear me call them vectors because they might get confused with B's over here. These are also vertices. Think of this as V and V prime or B and B prime. So now you know why I might be calling the V as in Victor and the B as in Bob's as Victors and Bob's. So anyway, so we know that those points exist. The other thing that we're going to know is that from our focus, if we go to each side of our ellipse, this part right here, this distance is called the lattice rectum, and we'll talk more about that as well. And we can see that also happens over here as well. Lattice rectum here. You can kind of think of this as two parabolas. If you think about this side over here as a parabola and another parabola on this side, kind of meeting up and joining in the middle, and we have two ellipses. So you can see that we have a focus, we have a vertex, we have lattice rectum similar to that of a parabola. So now let's talk about some equations and what we know and how we get our information. Here we can see the two associated equations with our two ellipses. One thing to remember here, you see our H and our K. That is going to be our center. So we're going to notice that the center is going to be the point H comma K. And that is true for both ellipses. So you might want to start putting this information below. So I'm going to go ahead and do that. That we figured out that the center is going to be HK for both ellipses regardless of whether it's a horizontal ellipse or a vertical ellipse. So that's the first thing. The next thing we're going to notice is that if you want to get to our vertex, that distance, here's our V and our V prime, that distance is going to be A. That's this little case A that we find right here. Notice this A is underneath the X's where the X squares are. That tells you that we're going to go horizontally. Notice A is over here under the Y, so from our center to our vertex, this distance is going to be A. So we can also go find B as in Bob. Remember, B as in Bob are here, B and B prime, and that distance is going to be little b, and we find that under the y's, so that means we need to go up and down. Same thing over here, we find b and the x's, so from our center we're going to go this distance b and this distance b to find b and b prime, or Bob and Bob prime. I'll make sure I put the prime right there. All right, so last but not least is where do we find our two foci? Well, our foci are going to be in between our vertex Victor and Victor prime. It's going to have a focus here and a focus here. That distance for F and F prime, that distance is little c. And notice we don't have a little c in our formula, in our equation, so we're going to have to come up with a relationship. And that relationship is that c squared is equal to a squared minus b squared. So we have a squared, in fact, we have b squared, we just need to subtract them and that will tell us the distance of c squared, or in our case, c. One big thing about ellipses that we need to note is that a is always greater than b. That a is always greater than b. So go ahead and put that up here. This has to be true for an ellipse to happen. If a is equal to b, we actually have a circle and not an ellipse. So therefore we have to make sure that one set of number is larger than the other. So if you don't see, we won't label a and b, you have to recognize that a is the larger number all the time. And that kind of makes sense because what we want to happen is that we want to stretch it horizontally more than we do vertically. So that's the reason why a is bigger. And notice a, because it's bigger, it's under the x's, it's going to stretch it horizontally more than it is vertically. Over here, a is under the y, so it's going to stretch it more vertically than it is horizontally. So this is how we get our vertical ellipse. So other things that we actually know about our ellipse is going to be the major axis. Our major axis contains the vertex v, it contains one of the f's, the center, the other f, and the other vertex. And that we call the major axis. So I'm going to write that information down here, that we know that the major axis is actually going to be the segment from v to v prime. It's that measurement. And that's true for both sides, both ellipses. We also have a minor axis. That minor axis is going to be from Bob to Bob prime. Notice it will be smaller than the major one all the time. And that's the same for both of them. So the distance of the major axis is going to be 2a, and the distance for the minor axis is going to be 2b. And that's true for both ellipses. So I'll write that down here. The other thing that's true for both types of ellipses is the lattice rectum. So let's talk about the lattice rectum. Lattice rectum. Remember that the lattice rectum goes through the focus and hits each side of my ellipse. Our equation, regardless of which one we're talking about, is going to be 2b squared over a. So the lattice rectum is going to be 2b squared over a. So let me show you where that is in our ellipse. So if we come down here, our focus is here. Our lattice rectum will be an L and then goes through the focus, and here's R. So there's two of them, lattice rectum, so you can think of that as prime, goes through the focus to the other end, and there's our R prime. And likewise here, if we knew what our focus was, each end will be our endpoint of our lattice rectum. Again, over here will be our focus, and each end of the line that goes through my ellipse, through the focus, will be the endpoints of my lattice rectum. And again, just so that we can tell them apart, I labeled one set L and the other one L prime. Last but not least, I think we kind of figured out everything, but you're going to be asked to find what the center is, the points of the vertices and the points of the foci. So let me show you a quick way of thinking about it. Think about it as everything coming from the center. Once I know the center, then I can find Victor and Victor prime by adding and subtracting a. If I want to find the Bob and Bob prime, all I have to do is subtract b, or add b to get to the other side. And likewise for the foci. So let me show you that we can find from our center, I'm going to write it down again, that we can find our vertices, and I'm going to call them the v's and the v primes, well, it depends. For this one, since it's going to be horizontally, we're going to get our h, our x value, and we're going to add and subtract little a, and we're going to keep the same y value. And that will give you the endpoints of your vertices for vectors and vector prime. Over here on the vertical ellipses, what's going to change are the y values. So my vertices here is going to keep the same x value, and to the y value we're going to add and subtract little a. If you want to know Bob and Bob prime, we do the exact same opposite kind of thing. So to find the Bobs, notice if it's this way, our Bobs are going to be up and down, so the h stays the same, and the k we add and subtract little b. For on our ellipse going vertically, if you want to find Bob and Bob prime, we got to go left and right. So for those, we're going to get our h, and we're going to add and subtract b, and keep the same y value as our center. Last but not least is the foci, and the foci work just the same way as the vertex. So they're going to be the changing of h, or x component, to plus or minus c, and keeping the same y value. So these two look very similar. The only difference is the changing of a and c, the distance of how far you go. Now remember, c will always be less than a, so it will be inside the ellipse. That information is important when we talk about hyperbolas in the next lesson. Remember, they go just like the vertex, so I'm going to keep my h, get my k, and I'm going to add and subtract little c. So that concludes all the information that we need about ellipses. In the next video, we're going to do a few examples about how to use these equations, how to graph them, and how to come up with equations. That concludes this video.